Well, I'm recording what I'm talking about, but whatever you write on the board isn't going to get recorded because you're writing on a chalkboard, not on my computer screen. So no one's going to see that. But, if we talk about some of this stuff, you might want to have, I don't know. Second hour asked me to record this when we're doing it, so I'm just recording it here also. So if I called you, Lazara, Lanfear, and Yaldo, why don't you guys come grab a marker and try to work on 1, 2, 3 respectively.
All three of them?
No.
Oh.
You're working on 3, yep. And Lazara on 1, Lanfear on 2. Again, if you don't come up with anything or it's not right, it's not a big deal. If you are not one of the people that are working on the board, what should you be doing?
Writing.
Trying to do it on your own, either in scrap paper or in your OneNote or whatever, just, or even if it's just like I'm going to think about it in my head and kind of work through it there. If you can do that, kudos to you. Probably most of us can't, and that's okay. You don't need to. And you guys can write wherever, like
in the middle of the...
Yeah, you can write on the screen if you want to. That's fine, not a big deal. I'll scoot a little bit out of your way, make you some space.
Or to be honest, I don't know how to do approximations whatsoever.
So when it says linear approximation, what are we really talking about?
Guessing what it equals.
A tangent line.
Okay.
So you need to write the equation for a tangent line. So if you see the information, do you have a slope and a point?
You have a point, right? X at 5 and then equals 3.
Okay, good. And then do you have a slope?
Yeah, because you have the derivative.
Okay, so use that to write the tangent line, and then plug in the 4.8.
What is it, like 3 plus? Is it 4? What is minus 5? What is y the?
Yep.
Like minus 3.
Well, you did the 3 already because you have 3 plus, right? You already moved the 3 over. Yeah. And now you're just plugging in.
Then
Just gonna plug in the 4.8.
oh,
That's it.
is this it?
That's it. So it sounds scary, but it's like,
harder than
it's like a nothing burger, right? Like again, the whole idea is just like writing an equation for tangent line, plugging the value in. I think that's negative 0.2 though, bro. My eraser's that red shirt on the ground, but fingers are fine. That's it.
hey.
Yeah. That'll do. Right?
Now I know how to do approximations. Thank
Right?
you.
Yeah, that's not so bad.
They're doing too much here. Like, I don't know.
No, yours is,
You guys are pulling. I have a question.
yeah.
So in terms of simplification, you said that we just have to be able to simplify until we match the multiple choice, right?
You just have to be, you don't, yeah, like if it's a multiple choice question, you can stop when you're confident you know the right answer.
Yeah, that's what, I don't know, I think that works best for me, but I just
Yeah,
wanna make sure that
yeah, you don't have to,
it's not.
yeah, just stop when you know which one it is. Totally fine. And I would say as well to you guys that the format for this test is you get the calculator for the multiple choice. So if any of these are problems that you'd like to do with a calculator, when you come up to do this, feel free to bring a calculator and just do it on a calculator if you want.
Okay.
That's okay.
Can you tell me where I'm at with this one? I don't really know how to where to go here. I thought it was a cheat roll. When I did the whole thing wrong then.
I looked at it and what? Because I don't want to think about it over my weekend.
Okay, this is gonna be easier than just a regular
It's
No, so it was funny, because I was looking at bio on 74, so. know. I have a concert on Friday.
This is not good. Okay, just go, right?
But that was really like, I could have gotten that one easy.
So, I'm gonna chain rule here for this one.
Yes, I would do that as a chain roll.
Is this right so far?
So
I'm sorry, you could
when
have
you
said.
did the derivative, so the outside is x to the fourth, but it's going to be then 4 inside to the third, and then it's times
Oh,
the derivative of the inside.
alright.
So from here, your derivative is done. I would just plug the 1 in.
You guys, this video is recording on
Right, I wouldn't do any expanding. You could, like, it's not wrong to do that, but like, whoa, save yourself the trouble,
Guys,
right?
I really want.
Absolutely. Use that, sorry, sir.
Mr. Bullock,
Yeah.
I forgot my phone in this Elwood's room. Again, can I go grab it? Thank you.
And BB. Oh,
I'm so clumsy.
guys, today felt like a Friday, you know?
Yes, it did.
I think you mean minus though, for the quotient. You wrote minus on your step above, but then you changed to a plus.
And then, is that it, or am I keep going?
Well, I mean, if you can get to look at the multiple choice, right?
Oh,
You don't have to
Forgot about that one.
like you just need to simplify it enough to so you can tell which one it is.
what if I just take an educated guess? Where should I go to simplify this?
Well, x plus 1 minus x is 1. Okay.
You just plug in.
Is it A for number two?
I think so. So write A, because that's what you got, right?
Oh.
You have to predict that.
Found it. Well, I did it correctly in my head, Mr. Cool. I did number 1.
What happened to the fourth power?
It's distributed it in. I don't know.
No, I mean like with what you just wrote with your arrow. Why isn't it 5x to the fourth over x plus 1 to the fourth?
That's what I meant.
Okay. And then what's x plus 1 to the fourth times x plus 1 squared?
Is it plus or multiplying it?
Multiply x plus 1 to the fourth times x plus 1 squared.
Can I just say the 8, right? Can I do that?
I mean, does that look like a
No, I added things.
I am starting my car and I'm walking.
So which one do you think it is?
D.
That's the correct one.
Alright.
All right, so looking at these on number 1, it asks you to do a linear approximation. When you hear linear approximation, all you're doing is writing the tangent line. So I have a slope of 4, because the derivative at 5 is equal to 4, and the point 5 comma 3. So Christian wrote his tangent line. Equation y equals 3 plus 4 times x minus 5. So he did point slope and then added the y1 over or something. Whatever, that equation is fine. Doesn't matter because we're just looking for a number anyways. But you can rearrange it however you want. And if we're looking for the estimate at 4.8, you just plug 4.8 in for x and evaluate. You got 2.2, which is what you should have. everybody okay with that? The takeaway, linear approximation is
Tangent line.
tangent line. That's it. You probably plug something into it later on, but like you're just writing the equation for tangent line. Should be easy. Those are gimmies, right? We've been doing tangent lines for this is test 3 that we've got tangent line questions on, right? We should be good at this. 2, Christian did this by hand, which is fine. So he did it as a chain rule problem. So he did the derivative of the outside. The outer part was x to the 4th. So we have 4 times the inside to the 3rd. And then he has times the derivative of the inside, which is just 2x. Then plugged 1 in for the x's and simplified down to get negative 64, which is correct. Alternatively, since this is asking you for a derivative at a point, you could do this all on the calculator. So if I type in the function into y1, I can do math and pick n derive, differentiate with respect to x of y1, so vars over to y vars, function y1, when x is equal to 1. And negative 64, right? Could do that. On any problem on the multiple choice, we're asking you for the derivative at a specific value of x. That can be done in your calculator.
Can you go over those steps one more time?
Typed into y1. Back to the main screen. Math. And then I pick n derive. So it should be a ddx problem because we're differentiating with respect to x. We're taking the derivative of y1, so vars, over to y vars. From the function menu, we pick y1. And the x value is that we're evaluating at is 1. And then I just press enter. So I did all of what Christian did by hand with the calculator. Any derivative at a point can be done with the calculator. Okay? If you have it's a calculator active section, don't do any of those by hand. Just let the calculator do it. Nolan?
Could we also use that to like check our work?
Absolutely, yeah. So if you're doing a derivative like Giselle did number 3, it's a indefinite derivative because we're not asking for the value. But you could pick a value like 2 or something. So if we went and took the problem and we typed it in here, so there's the problem. And then we'll take Giselle's answer, which was 5x to the 4th over x plus 1 to the 6th. And if we go math, derivative, respect to x of y1. Pooper scoopers. Needs to be over there. Function y1 at, say, 2, doesn't really matter. I get this number. And if I do y vars y2, evaluated at 2, I should get the same value, right? And if I want that as a decimal, right there. Same decimal, right? What should that tell me?
You're right.
Pretty confident that I have the right answer. So yeah, Nolan pointed out that yes, you could use this function also to check even a problem like number 3 that's an indefinite derivative because you're doing it just with respect to x and not plugging any value in. But just pick a value and check your answer versus what the calculator says. When you plug the number in, that's a good checker. And in fact, you could just start with type these 5 in to y2, 3, 4, 5, 6, and just do the same thing and just evaluate each of these at 2 and do the derivative of this with respect to 2 and just see which one matches. If you have no clue how to do it, you could still do that, right? A little bit more time consuming, so we wouldn't want to have to do that every single time. But like that's an option. If you're stuck, better than nothing, right?
Yeah.
Do you guys get what I'm saying? Chanel?
Wait, so if you were to like pick a point for that one, would it be the same, would you get the same answer for the derivative? So,
Yeah.
okay.
Yeah, so if I evaluate each of these at 2 and I did the derivative of this with respect to 2, I should get the same decimal. That's what we're just checking here.
Okay.
So now, what could go wrong? It's possible that the value at 2 might work for more than one of these. What would you do then?
Graph it?
I'd just pick another one. Just pick another value and see if it works. You know, the ones that tied for 2, see if they get, you know, do 3 then. Should get a different number for, you know, 2 of them should work. Or just one of them should match the other one. You shouldn't. It'd be really unlucky to pick 2 separate numbers randomly and have them both, you know. Like, I don't know that they could be that sneaky. All right. And then Giselle did this one. This is just a straight chain rule problem, right? So the outer is x to the 5th. So I have 5 inside to the 4th, and then times the derivative of the inside, which is a quotient rule. So when you do that quotient rule, you get 1 over x plus 2 or x plus 1 squared. And then it's just some cleanup from there. But Giselle's work looks good. Everybody's cool? All right, let's look at the next 2 here, I guess. Let's see who's going to do these 2. I have Brooke.
Yes.
And, oh, not Natalia. She's not here. Joey.
Okay, I do not 5. I do 5.
Sure.
I don't want to do
Use that
that
one, the
actually.
eraser.
It's just you gotta think creatively about it.
It's a lot of letters.
Okay, let me just roll my chair out of here real quick, Brooke.
Sorry.
That's okay. Just makes it easier to see what everybody's doing. You don't want to make comments while you're working. Yeah, it is just a little dirty t-shirt. As it gets older and dirtier, it's not gonna get any newer and cleaner. Oh man.
Is tan, or is it tan secant squared?
The derivative of tangent is secant squared. If that's what you're asking.
Yeah.
Okay. Wow, okay, I just got it. So Joey, start by taking the derivative of g.
Yeah, all right.
Because you want g double prime. You get that, you should be able to figure out what h is, right?
So that would.
It's a chain rule, right?
For.
So the e to the fx is a chain, right?
Yeah.
Where the outer function is e to the x and the inner function is fx.
Yeah.
So the derivative of the outside is just going to be e to the inside.
What was the inside?
Fx.
Oh, okay.
Yeah, it's going to be abstract. And what's the derivative of f of x?
F prime of
Yeah.
X?
Yep. So just times f prime of x. So that's g prime, right?
Yeah, so
Now you need to get g double prime.
that would be. That was right?
So what am I, that last piece of your sum, what am I looking at there?
The derivative of the first times just the.
So when you did the derivative of e to the fx,
Yeah.
you got e to the fx times f prime, right?
Yeah.
When you did it for g. So what happened to the f prime at the end?
Hold on. So it's this.
So like, when you did the derivative of this,
Yeah.
you got this, right?
Yes.
But where is? I'm missing another f prime of x.
Okay. So. Oh yeah, because you have to take that change also. Then am I saying this equal to that?
Sure, you can say h of x times e to the fx is equal to that stuff, sure.
Can I go in the back of the room and check my computer?
No. Sure.
Sorry.
You're fine.
Thank you.
Is that one of the options?
I kind of forgot their options.
Yeah. Okay. Which one was it?
D.
Good. Yeah, that's correct. So on 4, this I think is a lovely question because it's. I think the AP likes these kinds of questions that are a little bit abstract that like really force you to do you understand the notation here well enough to where you can do this calculus even though there's not like a specific function for you to do the derivative of. So what Joey did is he started just by taking the derivative of g, which is the derivative of e to the fx, which is a chain rule. So the derivative of the outside was e to the fx, and the derivative of the inside should just be f prime of x, right? We don't know what f is, so we just write it as f prime. If you looked at the answers possible, hopefully you'd see pretty quick that like, okay, it's fine to have f primes and double primes and stuff in there. Like, I'm going to have that stuff, no big deal. Then we do the second derivative. So there, that's going to require a product property. So we have e to the fx times the derivative of f prime. So that's just f double prime. So the first piece is e to the fx, f double prime of x, plus, and then we have the derivative of e to the fx, which we did already, right? That's e to the fx times f prime of x. And then we still have that extra f prime of x at the end. And then from there, well, that's g prime or g double prime. So we set that equal to h of x e to the fx. Joey did some factoring. Could have at that step just divided both sides by e to the fx also. Doesn't really matter. And just a little bit of algebra. F prime times f prime is f prime squared. You're there. You're at your answer. Again, hopefully if you had made it to getting g double prime and then looked at the answers, should have been pretty obvious which one you would have wanted to pick there. Wouldn't have taken a whole lot of effort to see that. Number 5 is also correct. That's just a double chain rule, right? So the first outer function is e to the x. So the derivative of that is just e to the inside, so e to the tan squared x. Then you have the derivative of tan squared x, which is another chain rule. The outer function is x squared, the inner function is tan x. So the derivative of the outside is 2 tan x, and the derivative of the inside is the derivative of tangent, which is secant squared. So there's what Brooke got, and we can see right away that's got to be choice D. Everybody so far so good? Is this helpful to kind of like sit through here and try to struggle through some of these? It's a slightly different experience than just watching Mr. Kulik do these flawlessly or whatever. All right, let's see. We got 3 now. Let's see. Who are going to be our lucky 3 people? We have Audrey and Tony and Ben. You can do that.
I have 8.
Okay, I just want to make sure, because I was solving it last night, and I wasn't sure.
You're right.
The way that I did it is I just did it the way it looks. So I did the outside, so 2x plus 2, and then plug the ln in, and then times the inside. I just looked at it as a change, right? F of ln x. So that's just going to be f prime of ln x times 1 over x. And f prime is 2x plus 2, so just plug.
And then you plugged in the ln x times 1 over x.
Yep, and just wrote it all over.
Okay, cool, thank
Yeah.
you.
Either way of thinking about it, you can get the same thing. It's not much different.
Okay, got it.
Can I like take a picture of my work and like write it on the board?
You can bring your tablet. Yeah, that's fine. Yeah. You can carry that up there. I don't care. Whatever.
It's so legal.
If you guys, there's that red towel or red t-shirt sitting on the floor if you need to erase some stuff too. If one of you can do this, the other one should be able to do it because they're almost the exact same problem, right? Now everyone on 7 and 8, there's an opportunity to make this problem much easier with a little bit of algebra here. Take a look at 7 and 8, see if you can tell what you could do to make this much easier. I would not do that. Yeah. So instead of thinking of that as 1 over x or 2 over x, what if I just think about x to the negative 1 or 2x to the negative 1? Why would that make life much easier? You eliminate the quotient rule being necessary. Way easier, right? Big time saver.
Are we on the right track?
Yeah.
I think we're on the right track.
So I would rewrite your starting problem instead of e to the 1 over x, e to the negative x. Instead of e to the 2x, I'd write that as e 2, or e to the 2x to the negative 1. And I think that will make life much easier. Because now it's just a straight chain rule problem. Oops, I bumped my desk. For whatever reason, that always. So it's a chain rule now, right? What's the outer function? E to the x for both of you guys, right? What's the derivative of e to the x?
E to the x.
So you have e to the insides. That's your first piece.
So
in Ben's case, that's e to the negative x. In Tony's, that's e to the negative
2.
Or I'm sorry, e to the. Sorry. Let me rephrase. In Ben's case, that's e to the x to the negative 1. In Tony's is e to the 2x to the negative 1.
oh,
And then you have to do the derivative of the inside. So in Ben's case, the derivative of e to the negative x. In Tony's case, the derivative of e. I'm sorry. Ugh.
what's the derivative?
I think this would be -2. This.
So, right?
Yeah.
I want to do the derivative of this. It's going to be that times the derivative of that. Right?
Oh, yeah.
And that's just out.
So then that's
So you. Right?
Should be -2. -2, I think this would be -2. I think.
power.
I think so. Look at the answer choices too.
And that's what
Circumference is 2 pi r, area is pi r squared.
There's so it's gonna have to be over that.
actually. That stay as that stay as one answer.
So once you think you've got enough to figure out what the answer is, you can go ahead and just write the letter, right? So those are both correct. Again, before you dive into a problem, worth looking to see algebraically, is there a way for me to make the calculus here easier? Can I avoid having to do a quotient rule, or a product rule, or a chain rule, or a power, is there a way for me to rewrite this to reduce the layers of calculus I have to do? On this one, by rewriting x to the negative, or 1 over x is x to the negative 1, or 2 over x is 2x to the negative 1. We remove having to do a quotient property, which anytime I can remove having to do that nightmare, I'm a happy camper, because that's the worst one, right? It's the longest rule, it's the most writing, it's the one that is easiest to screw up because you have like the subtraction in there. If you do it in the wrong order, you're busted, right? So if I have the option, like, let me get rid of that right away. And then on 6 is just a chain rule problem, right? So the derivative of the outside, so you're just doing f prime of ln x times the derivative of ln x. F prime is 2x plus 2, so if I plug ln of x into that, I have 2 ln of x plus 2, and then I multiply that whole thing by the derivative of ln x, which is 1 over x, and I have 2 ln x plus 2 over x. So all three of these look good. Alternatively, for number 6, you could have started by just plugging ln of x into f of x and differentiating that, which I think, based on the work that I'm seeing, is probably what Audrey did. And that's fine. You can think about it that way also. Either way is okay. You'll get the same result. Oh, 9 is going to be the only one that fits here. Who's going to get it? Nolan! It's all you, big guy. Might be the easiest one in the set. Someone's making faces at me like, I don't know what you're saying about easy. Or maybe he's like, I got it. You should be able to do it. This is one that you can do in your head, actually. Yep, you got it.
Oh, that's just it.
Nope. It's a chain rule.
Oh. Oh.
It's okay. You can't erase it out of the paper. Any questions about this one? This one ideally was pretty straightforward, right? Ooh, scary number 10. All right, who's going to get that one? It is Katie.
No.
And Holden, you have 11.
Mr. Cooley, this is a lost cause.
It is not.
Did you use this?
Yes, that's our erasers, the dirty t-shirt.
You want to do 10? You want to do 10?
You can do it.
I don't know, Mr. Cooley.
Ooh. Katie, what does h of g of x equals x mean? Not sure?
No.
Okay, start just by taking the derivative of both sides of that.
Both sides. What do I do then?
Just like a chain rule. That's fine. The derivative of x. Okay. And now, what is the question asking for? G prime of 7. So, how do you get G prime by itself? Oh, hold on.
What happened?
There's two changes.
Oh, really? Do it. What I miss?
So when you do the derivative of cosine x or cosine
Oh,
4x,
it's derivative of 4x too.
then you have the derivative of 4x.
Oh, okay.
Can I get my print? It's, I printed this out.
Yeah.
No problem. Okay, good. But what's g of 7?
Does it give it to us? No.
It doesn't, right?
Yeah.
But it does, just not in the way you're expecting.
Oh, it's like, G of 7 is 8.
Oh my god, like that's what you're like?
So here's the trick. Okay,
Yeah.
I know that h of 3 is equal to 7. Right? Yeah. I do g of each side. What is g of h of 3? So if I have like h of g of 3, what's that going to So what is g of h of 3 is equal to? That's tough. Ah! It'll come back. There it goes.
oh, that was tough.
Yeah. That's the toughest one we've seen in the first 10. Just so you know. All right. So 10's correct. So when we see h of g of x is equal to x, what does that mean?
The inverse?
Means that h and g are inverses. Now, if you didn't remember that, you would do what Katie did, which is just take the derivative of both sides of that. But if you remember that that statement means that h and g are inverses, you could go straight to g prime of x equals 1 over h prime of g of x. That's the formula for the derivative of two inverse, or derivative of an inverse. We did that in the 3-4 bonus, I think, right?
Yeah.
That's where we did that. So we did that to get our equation then for g prime. So we plugged in the 7 to g, or into the x for g prime of x. Now here's the tricky part. I have g prime of 7 is equal to 1 over h prime of g of 7. What the heck is g of 7? It's not in my table. All I have are h and g. So what we want to do is we observe that h of 3 is equal to 7. That's in my table. If I do g of both sides of that equation, I have g of h of 3 is equal to g of 7. So there's a g of 7, right? That's good, I need that. I just need to figure out what g of h of 3 is equal to. Well, if h of g is equal, or h of g of x is equal to x, then g of h of x has to be equal to x also. So, just 3.
I didn't understand it. So where did you get the 3 from for g of h of 3 down there?
Look at what we have. Given this, so if I put a 3 in for x, h of g of 3, it should be equal to 3, right?
Okay. So in this case, oh, so it would just be 3. Yeah.
So
That's just
this
the formula for
is just
3. Okay, got it. Thank you.
That's the trickiest part, is that they didn't give that g of 3 2u, or g of 7 is equal to 3 2u. You had to figure it out. The other way to think about it is, if I know that h sends 3 to 7, and g is its inverse, what does g have to do? Has to send 7 back to 3, right? Or, in other words, g of 7 has to equal 3. You think about it that way also. But if we didn't recognize that that meant inverses, I didn't suggest that to Katie because, well, we didn't remember it. And that's okay. But it's easier if you remember that that statement means that those two things are inverses. And then it's not so bad. 11 is correct. So holding that first, forgot that there was two chain rules here, that when we do the derivative of cosine 4x, that's a chain rule also. So the derivative of the outside is negative sine, but then we also have the derivative of the inside, 4x. So we forgot that at first. So I add that extra times 4 to get to the negative 12. Easy to forget that. Everybody okay? Questions on these two? Is this helpful? Doing these just slowly as a group or whatever? All right, let's see. We got next two who are lucky victims. Ava, just in time, back. And then Chanel. So 12 for Ava, 13 for Chanel. Again, that dirty red shirt on the floor is your eraser. So erase whatever you need.
Oh, my mom's from Canada. No, sorry.
It was for a Halloween costume from about 10 years ago. So
Oh, okay.
it has nothing to do with Canada being the erasing shirt. It's just a shirt that I didn't need anymore that I'm like, oh. Oh, excuse me. These will probably be the last two that we do.
Mr. Fulick, I don't remember the I know I have to memorize it. The
I
thing.
think it's 1 over 1 plus x squared.
Okay.
Think. Can somebody double check that for me?
Yeah,
The derivative of
tan
tan inverse. You guys got your OneNote open? It's at the end of. Oh, good. I was right. I couldn't remember if it was that one or the negative of it. Cotangent's then the negative. Cotangent inverse is negative 1 over.
Is this correct, Mr. Fulick?
Looks great.
Thank you. Okay, that is B.
Very good.
You're not more track.
So it'd be the derivative of the outside is negative sine 3x, and then times the derivative of the inside, which is just the derivative of 3x. And now you're just going to plug pi over 9 in for x. Try reducing 3 pi over 9. Sine of pi over 3 on the unit circle. Who remembers? All of you should. Nope, that would be pi over 4. That square root 2 over 2 is for pi over 4.
There's a 1/3.
Not 1/3. That's never a unit circle. Square root 3 over 2. That is correct. So sine. Here's the way I remember it for sine. You're talking about the y coordinate on the unit circle. So the 3 angles in the first quadrant, 30 degrees or pi over 6 is the smallest, 1/2. The next one is the 45, root 2 over 2 or 0.707. The biggest, 60 degrees or pi over 6, or I'm sorry, 60 degrees or pi over 3 is root 3 over 2, like 0.866. So that's, I know, is the biggest one because it's the biggest angle in the first quadrant. That's the way I remember it. And if you remember the first quadrant, you can really kind of figure it out for any other quadrant afterwards. That looks good. You got the negative sign in there, a little teeny tiny?
Yeah.
Okay. I couldn't tell for sure because I'm way over here and all eyes and stuff. Good. So, Friday. If you want to take the test on Friday, you need to let me know tomorrow. Okay? So find me sometime tomorrow. If you can't find me, send me an email, okay, before the end of the day of school, please. If you are in class, we're going to do 3-9 and then take some more review questions or whatever. Next week, we'll do the test on Tuesday, and your asynchronous day, I'll give you some more 3-9 practice from the MyAP site. So no new content delivered on the asynchronous day, just practicing stuff from 3-9, which is hard.
I'm just curious, is it accuracy and stuff?
Good afternoon.
Just trying, okay, good.
Okay.
I just wanted to pick stuff that at least
Let's close today in prayer. Dear Lord, as this day comes to a close, we thank you for your guidance and blessings. God, for your protection and peace throughout the night. Watch over our loved ones and grant us restful sleep. Pray this in your name. Amen. In the Father, Son, and Holy Spirit. Teachers dismissed at the bell. Thank you.
Thank you.
Bye. You're welcome.
Be very.